Dear students, today I am going to discuss about superposition principle of waves. Superposition principle of waves. Class 11 Science, Chapter 15. What is superposition principle of waves? Suppose two or more number of waves when superimposed, then we will get a resultant wave. The displacement at any time of the resultant wave will be equal to the vector sum of the displacement of the individual wave. What is said? If two or more waves superimpose at any time, then the displacement of the resultant wave, we will get a resultant wave. The displacement of a resultant wave will be equal to the vector sum of the displacement of the individual waves. Suppose there are n number of waves. One displacement is y1, other is y2, other is y3, like this. When n numbers of waves superimpose, then we will get a single wave. So it has also some displacement, and the displacement of the resultant wave will be equal to the, say this is y, this displacement of the resultant wave will be equal to the vector sum of the displacement of the individual wave. That means this is equal to y1 plus y2 plus, this is the superposition principle of wave. Superposition principle means overlap between two waves or more waves. Clear? When two or more waves superimpose, then the displacement at any time t at any point will be equal to the vector sum of the displacement of the individual waves. This is the superposition principle. In any way, we will get superposition principle. And due to superposition of waves, three phenomena occurs. One is interference of wave, another is beats, another is stationary. Due to interference of waves, we will get interference, we will get beats, we will get stationary waves. Now, reflection of waves. Reflection of waves. Suppose there is a fixed position, fixed boundary, and in this boundary a string is and if you give jerk on this side, wave pulse will be produced. Say the wave pulse is moving here to this. And at this point, it is getting a force in this direction. Clear? And when after reflection from the from this point, B point, the wave pulse will turn back, but this will turn back in the waveform. This is called trap. Here, this. When it is moving in this direction, and after reflection it is coming this. So when wave is moving in this direction, equation of progressive wave is y equal to r sin 2 pi by lambda vt minus x. And after reflection, it is moving towards negative x-axis, and there is a phase difference. This and this, in between these two, have a phase difference pi. So equation will be, this is when it is moving, and this is after reflection on the fixed point. Y equal to r sin 2 pi by lambda vt plus x plus pi. Clear? And this means it will be minus r sin 180 plus theta means sin theta, but third quadrant negative. So minus sin 2 pi by lambda vt plus x. So when a wave pulse wave is moving towards the positive x-axis, equation is this, and after reflection from a fixed point, the reflected wave has a equation y equal to minus r sin 2 pi by lambda vt plus x. This is the, if the boundary is fixed, and if the boundary is not fixed, then what will happen? You see, there is a suppose ring. This is, so there is a force in this direction. So what will be the equation? This point is fixed. These two cases, and this point is open. Equation, what is the equation? Y equal to r sin 2 pi by lambda vt minus x. After deflection, what will happen? This case also, since this side is free, so F will be invisible. And now the wave is, they are in phase, same phase. So there is no change in phase, only direction is changing. So equation will be y equal to r sin 2 pi by lambda vt plus x. So in case of reflection, if a wave moves towards the positive direction of x-axis and from a rigid support, after reflection it will turn back, but it is seen that in opposite phase it is coming back, and so equation will be minus r sin 2 pi by lambda vt plus x. But in case of open portion, if the other end is open, not fixed, then what is the equation of the refracted wave? This is y equal to r sin 2 pi by lambda vt plus x. This is fixed, this is open. Equation is this is minus r sin omega t, r sin 2 pi by lambda vt plus x, and in this case r sin 2 pi lambda dt plus n. These and these are the reflected wave. This is in case of fixed end, and this is in case of open end. Yeah. Now question is stationary wave. Stationary wave. Stationary wave. Stationary wave means wave is not moving. So if two waves having same wavelength, same amplitude and having the same velocity and they are moving in opposite direction, after superposition they will give stationary wave. Two waves having same wavelength, same amplitude and have the same velocity but moving in opposite direction, and after superposition they will give the stationary waves. Four criteria. What I have told? One is same wavelength. Second, same amplitude. Third, same velocity. Fourth, moving in opposite direction. After superposition, they will be stationary wave. Two waves having same wavelength, same amplitude, same velocity, but moving in opposite direction. After superposition of the two waves, it gives stationary waves. Now, we will get stationary wave for stationary transverse wave, stationary longitudinal wave. Transverse wave means in case of string. In case of string, longitudinal means in case of air column, musical instruments जो है in this case. Now we are going to find the equation of stationary wave. Equation of stationary wave. Equation of stationary waves. So we need two waves. One should move in this direction, other should move in this direction. So y1 equal to r sin 2 pi by lambda dt minus x. So this is moving in positive x-axis, and reflected wave will be y2 equal to r sin 2 pi by lambda, this is minus dt plus x. After superposition, what we will get? Y equal to y1 plus y2. Superposition principle. So add this. So r sin 2 pi by lambda 50 minus r sin so you take common minus r. If you take common minus r, then what will happen? This and this will be minus. Now what is sin A minus sin B? Sin A minus sin B means cos A plus B by 2 sin A minus B by 2 twice cos A plus B by 2, and I will do the outside cos A plus B by 2, so 2 pi by lambda Vt plus x plus Vt minus x by 2 sin A minus B by 2 sin 2 pi by lambda Vt plus x minus Vt plus x by 2. So it is coming minus 2r. Here x is cancelled. Twice Vt by 2 means Vt. So cos of 2 pi by lambda Vt sin, here you see Vt cancel, so 2x by 2 means sin 2 pi x by lambda. Now 2r sin 2 pi x by lambda, just arrange cos of 2 pi Vt by lambda. Now we are taking this as amplitude. So A cos of 2 pi Vt by lambda, where minus 2r by 2r sin 2 pi x by lambda equal to 8 is the amplitude. Amplitude of the wave, stationary wave. A cos 2 pi Vt by lambda. This is the equation of stationary wave. This is the equation of stationary wave. So what we are getting? For stationary wave, we need two waves. One should move in this direction, other should move in this direction. And for this region, we have taken one incident wave, other reflected wave. Incident wave, other reflected wave. So this is the incident wave along positive x-axis. This is negative x-axis, reflected wave. And after superposition, these two superimpose. So y equal to y1 plus y2. This. Then we take common r, minus r. So minus r, if you take common, then this will be this and minus of this. And sin A minus sin B formula is sin A minus sin B is twice cos A plus B by 2 sin A minus B by 2. Twice 2 is taken out. Twice cos A plus B by 2 sin A minus B by 2. So from this we are getting this. Now we have taken this side and this is taken as amplitude. So this is the equation of stationary wave. Y equal to A cos 2 pi Vt by lambda, where A equal to minus 2r sin 2 pi x by lambda is the amplitude of the stationary wave. This is the stationary wave. Next day we will discuss about the different modes of vibration. Different modes of vibration of a string which is fixed in at the two ends. Okay.